Hello, everybody, and welcome to our OSDFCon webinar series. We really appreciate you being here, and we hope you'll get valuable information from today's webinar. This webinar is being recorded, and we'll be emailing out the link tomorrow to everyone who registered. So if you find it useful and informative, please feel free to share it with anyone who might be interested. Before we get started, let me introduce myself. I'm Ali Javine. I'm the event manager at Basis Technology, and I'm just going to very briefly go through some logistics. Now, you probably already noticed, but everyone is muted. So if you have questions anytime during the presentation, please feel free to ask them throughout, but we will wait until the end to answer them. To submit a question, just type it into the questions pane of the control panel. We scheduled the webinar for 45 minutes. After a very brief introduction from me, there will be about a 35 minute presentation followed by a Q&A session. When the webinar ends, you'll be directed to a survey, and we would really appreciate it if you could just spend 2 minutes letting us know your opinion. It does really help us learn, what you thought of the webinar and also what we should do on future webinars. So as mentioned before, I work for Basis Technology. We've been around for 25 years, and our cyber forensics team focuses on building easy-to-use software for the people who are on the front lines of cyber investigations. We built Autopsy, which is one of the most popular open source digital forensics tools in existence, and I imagine is what brings most of you here today. And we also make a tool for incident response called Cyber Triage, which is hyper-focused on intrusion-related investigations, and it automates as much of the process as possible. So without further ado, let's get started. I want to introduce you to Andrea Lazzarotto. As you can see, my Italian is impeccable, and he's going to spend the next 45 minutes with you to talk about RecuperaBit. Andrea works independently as a digital forensics consultant and software developer, and he's based in Italy. He is the author of RecuperaBit, an open source program for NTFS data recovery. And he also authored Carbon 14, an OSINT tool for determining the publication date of a web page. And a fun fact about Andrea, he's been practicing karate for 15 years and has a first-degree black belt. So you don't want to mess it with him if you see him on the street. So Andrea, take it away.
Yeah, thank you very much. Welcome to everyone. Good morning or good afternoon, wherever you are located. This presentation is focused on my open source software, RecuperaBit. As it was mentioned before, it is focused on NTFS reconstruction. So I'm a digital forensic consultant. I have a few interests in forensics and anti-forensics, WhatsApp messages tampering, and analysis of metadata on various social networks. And you can find my open source tools in Kane, for instance, or you can download them and install them on Linux, and actually on other platforms as well, because they are based on Python. So today's speech is mainly divided into three sections. We are going to discuss the main issues with damaged file systems, so what we can expect when we have to work with damaged NTFS or partitions. Then I will talk to you about the reconstruction algorithm, which is implemented in RecuperaBit. So I will show you a general overview of how it works, what's the main reasoning behind it, and so you will probably get the approach that is used to reconstruct the structure of NTFS partitions. And finally, I'd like to talk to you about the future development plans that I have in show for RecuperaBit, because there are some kind of aspects that need to be improved so that the tool becomes more useful and more user-friendly as well. So let's start with the first part, issues with damaged file systems and the problems that are related when to damaged or missing metadata. The main problem is actually that when we are facing damaged partitions, we might not be able to read them easily, especially when using standard tools like our operating system driver or simple data recovery tools, because if the metadata is damaged, probably we are not able to parse the directory tree, and so the master file table might be missing some records, or it might be partially overwritten by either accidents to the logical drive, or even deliberate user actions. For instance, a user might be wanting to reformat his or her drive, or otherwise might decide to try to make it unrecoverable, so the user might overwrite some parts. So in this case, generally speaking, one could always try to do file carving, because as you know, file carving is independent on the file system, so you might want to check if there are pictures or Office documents on a drive, other kinds of known file types. But as you know, file carving has some limitations. For instance, file carving does not give you the file names, and it doesn't give you also the timestamps or other metadata. So you might be finding some interesting artifacts, some interesting files, but you don't know whether they were stored in, I don't know, the downloads directory or in the browser's cache, whether they were allocated, whether they were deleted. So you're missing a lot of the context. And in general, when you're working with a lot of files, you would like to have the complete picture and maybe know exactly where they were located into the disk. So this is why file carrying alone might be limited. So here is an example of how metadata can be corrupted. In this case, the scenario is that a user decides to create a new partition with an NTFS file system on top of an old one. As you can see, the red file system is made of a boot sector, an MFT, master file table. A part of it is also mirrored into the middle of the partition, and then at the end you have the backup boot sector. And this new file system is overwriting a few records from the old one, which was for different size and located in a different place. So you have a mix of blue records and red records, which are interleaved. And so yeah, the red file system is probably perfectly fine and you know, pristine, you can read it, but the blue one is missing some records, so it might be unreadable or only partially readable. So while I was working on this project, I read Brian Scarry's book, which is a great one, File System Forensic Analysis. I suggest everyone who is interested in file systems to check it out. And there was this sentence that stuck to me because it says, there's unfortunately very little published in terms of the procedures used to perform recovery when metadata is missing. And that was precisely my interest. So I wanted to understand what it can be do when metadata is missing. But yeah, there wasn't a lot of material on this topic, so it made it even more interesting. So let's see what it can do. Our goal is to analyze and reconstruct the contents of NTFS partitions, even in a scenario where you have either missing metadata, some missing metadata, or some corrupted metadata. So the MFT might be partially corrupted, or some records might be missing. In order to also recover the contents, so we don't only need to rebuild the directory tree. So the directory tree just tells us how the directories and files were organized, but also we want to determine the partition geometry, because otherwise we cannot get the contents of the files. I mean, we can see the files were in a specific folder, but if we don't have the partition geometry, we basically cannot retrieve the file content. So we see files, but we cannot read them, and it's a pity. So yeah, this is our problem, and we want to do some heavy reconstruction and recovery even in bad situations where we are missing metadata. And now let's see what we can do and how we can actually reconstruct NTFS. Now this approach is a little bit complicated, but it can be broken down in a few steps. So this is a high-level overview. The first step we want to do is to scan the whole drive and read it the first time. Now, as I mentioned before, I'm not interested in data carving, but I am interested in metadata carving. So I'm actually carving not the files, but the metadata structures. So I want to see on a drive which kind of metadata structures are located on it and exactly what I can give them. Afterwards, I'm going to cluster the file because as you can see, if metadata is missing, maybe I don't have a partition table, I don't have boot sectors, but I find a lot of different file records in the drive. They may be pertaining to different partitions, and I don't want them to mix them to end up in the same partition. So I need to cluster them into different groups, and each group is a partition. Then, when my files are divided into clusters, I want to start rebuilding the directory tree so that I can see exactly how the directory was structured and how it was organized. Finally, when I have divided files into partitions, maybe I've already rebuilt the tree, I also want to try and figure out the partition geometry of each different partition. In this way, if I manage to do that, I can also restore the files. It is not always possible, but in general, we will see that often it's possible to do that even if some metadata is missing. Let's start with the first step, which is metadata carving. So we are looking for interesting artifacts. And in NTFS, we basically have 3 different kinds of artifacts. The first one is a boot sector. So as you remember from the picture we saw before, each NTFS system has 2 different boot sectors. The first one is the first sector of the files of the partition, and then it's copied verbatim into the last sector. So the latter is called backup boot sector. This is done because in a case when the first sector is damaged, the NTFS driver sometimes can use the backup boot sector in order to still be able to read the disk. And you see, oftentimes, if a disk breaks or is damaged in some way, usually the first sectors are those who get the most damage. So having it at the end of the disk can sometimes save the partition. Then the second important artifact is a file record. Each and every file on an NTFS drive has an entry, or actually one or more entries, because it can have many attributes. So there is a main entry, which stores the file names, parent directory, id, and timestamps, and so on. But if a file has a lot of attributes, it can sometimes have more than one record. But yeah, the important fact is that it has at least one. And also it points to the identifier of its parent. This will be very important in the next slides. Finally, when we talk about directories or folders, as Windows calls them, we have index records. And index records basically have a list of the child nodes which are contained into directories. So they are organized as B trees, and each index record contains a few files which are into a specific directory. So a directory can have many index records. So as I mentioned, it's important to know that files have an identifier of their parent directory, because we can use this fact to actually divide files into partition. You know, usually the MFT is not fragmented unless it becomes very, very big, but usually it's just a sequence of records which is contiguous on a drive. So what we can do is basically we check the whole drive, we scan every sector and read to see if we found an MFT record. If we found a record, we can keep track of its position on a disk and in sectors. And we also know that every single record is made up of 2 sectors. This means that we can compute the position, where the starting position of the MFT, assuming that the MFT is not fragmented. We can just take the sector when we found the file record. And well, actually there is a little typo here. It's not the identifier of the parent, but it's the identifier of the record. But you know, it's kind of the same reasoning. So it's the identifier of the record, not the parent directory. Sorry for that. So we can take the sector and subtract twice the identifier. In this way, we find the position, the starting position of the MFT expressed in sectors. Why do we do that? Well, we do that because if we have records from different partitions which are interleaved for some reason, we can easily split them and attribute each record to its correct partition. As you can see here, we have two sequences, one starting with 29 and the other one starting with 100. They are sequences of records belonging to 2 different partitions that cannot be in the same partition. It's impossible in this case. So we want to cluster them into different partitions. We apply the formula that we saw before, and basically we find that 4 records, the red ones, have all the same starting position of the MFT, and the green records also have the same starting position. So we divide them into 2 groups. So this was about the file record clustering. Afterwards, we can try to reconstruct the directory tree. Now, normally, when you see an operating system or a software which is not a forensic software, what it does is basically it starts reading the file system top down. So it starts from the root node, and it checks what are the directories which are contained in the root, and then for each directory, what are the children, and so on and so forth. So as you can imagine, if one single node is broken, corrupted, missing, overwritten, whatever, a large branch can be disconnected from the tree, because if you delete a record pertaining to a directory which contains hundreds of files, then if you read top down, the record is missing, then you have hundreds of files which are not connected to the tree anymore. But given that each file has also a pointer, let's say it contains its parent identifier, we can actually try and do the opposite. So we can start from each file and link it to its parent node. And this way we can rebuild the entire tree bottom up. Now, what happens when a directory is missing? Assume we find 5 files with a parent node ID of 25. We don't have file record 25 anywhere, so we don't know actually what was the name of that directory, but we know that there was a directory with the identifier 25. So we can create a dummy directory called dir25, and we can assign all of the files to the same parent node. In this way, at least we know those files were located in the same place. We don't know exactly where, but they were in the same directory. And this directory, where does it go? It goes in a collection which we call lost files, which is the parent node of files we don't really know much about. So here's a diagram to show this approach. As you can see, it's the same set of files, but on the left side you can see a top-down approach. So basically, on the right side of the left diagram, we have a missing node. This missing node has 2 children, so these 2 nodes actually get disconnected. But if we do the opposite, we can see the right tree. On the right tree, we have the nodes pointing to their parent. If a parent is missing, we actually create a dummy element, and then this element is linked to the lost files. And this way, we have rebuilt a single tree, so every file gets to be in the tree. Now let's go on about checking how to build the partition geometry. So partition geometry is essential because we have to be able to read files. We want to see the file contents. And this is usually stored into the boot sector. A boot sector essentially gives us a parameter which is called sectors per cluster. And it can be 1, 2, 4, 8, 16, or another power of 2. And it tells us that specific partition, the specific file system, how many sectors uses for a single cluster. Because in NTFS, basically all files allocations or run lists are expressed in clusters. So we have to translate clusters into sectors. And the cluster base is just the offset starting from the beginning of the disk that tells us where the file system starts. So if we have a boot sector, either we have that sector as the cluster base, or that may be the backup boot sector. In that case, we do a subtraction. We take the boot sector's position, we subtract the file system size, which is also stored into the boot sector, and then when we do the subtraction, we get the position of the original boot sector. So if we have a boot sectors determining partition geometry, it's very simple. We can just read the sector and get everything we need. However, there are cases where boot sectors are overwritten. Both of them might be missing. So in that case, we have to do another kind of approach in order to recover the needed information. And this is what I call the inference process. So we want to infer the partition geometry from what we have. And what we have is usually a lot of file records and several index records. Now assume we don't have any kind of boot sector available. So what we can do is that we have the index records, and we can actually check them. And you know, an index record does not directly contain the identifier of the directory they pertain to. So we have an index record. We don't know what is the ID of the directory. However, inside there are many file name attributes, and each of these file name attributes has the identifier of the parent directory. So what we can do is you read all of these attributes, figure out which is the most frequent identifier, because sometimes there are files which are actually hard links, so they can be put in a different directory, but most of the time you just get a single value, and that value you consider the identifier of the directory, which is the owner of this index record. And then you can also check that between among all of these MFT entries, you have some of them where that have index allocation attributes, and if they do, they are directories. These index allocation attributes have a run list pointing to the locations where their index records actually are on a drive, and these locations are expressed in sectors, and the sectors are relative to the start of the partition, which is the cluster base. So you have like an index allocation attribute that says my index records are at sector 11, at sector 25, and so on. And then you have somewhere on the drive some index records that say my directory has ID 46 or whatever. And so you want to take all of this information and put it together. So what you can do is you can try to iterate over different values of the sectors per cluster per meter. So you try 1, then 2, 4, 8, and so on. For each of these values, you try to build a pattern starting from this index allocation attributes. So you convert this kind of offsets relative to the start of the partition into a string, which has some elements which are filled with the ID of the corresponding directory. And then you try to match this pattern on top of the old drive, which is our, let's say, text, which is mainly empty, but it has a number in each sector where index records are. So if you get a good match, basically you can actually say, I have found that for this SPC value, I get this cluster base value, and the match is, I don't know, 99%. So I'm pretty confident that is the correct value. Now here is a picture, a diagram for you. Now let's assume I built this pattern with the SPC value of 2. So I have 4 clusters, and each cluster is positioned to index records of a specific directory. Each color is a different directory. And somewhere on the drive, I have these index records. So I can swipe the thing until I find that this is a good match. So I have a 100% match for sector per cluster is 2, and cluster base is, 4 sectors. Okay. This means I have a perfect match. And for this partition, I found the correct values, even though I didn't have any kind of boot sectors nor backup boot sectors, but still I was able to find the correct value. And yeah, this actually wraps up the second part, which is the partition geometry inference in order to be able to recover the files. So RecuperaBit is an open source project. It's written in Python. It doesn't currently have any external dependencies, so it implements a full-blown NTFS parser on its own. It does the reconstruction procedure, as we discussed before, and it has file recovery capabilities, so it can actually copy files after it has rebuilt both the directory tree and the partition geometry. So there is a little caveat here. It does not currently support NTFS compressed files, And this is mainly because really I was not able to find a lot of documentation on NTFS compression. So actually, if you have any kind of technical reference on how NTFS does compression, I would really love to get in touch with you. So maybe I can extend the software in order to be able to extract NTFS compressed files. And it's a command line tool which as we will see has still some aspects that could be improved. However, currently it has been used by several happy users. I've had people write emails to me to thank me because they were able to recover 500 gigabytes of data while they were trying, I don't know, some kind of cheap commercial software, and they were not able to restore a lot of files. So yeah, even though it's far from perfect, but it still has its merits, and sometimes, in some cases, it has proven to be better than commercial products. In case maybe the Italian users or those who speak Italian are wondering if the name is Italian, it's actually Latin. RecuperaBit is a verb. It means you will restore. But yeah, you can also read RecuperaBit, which means bit restorer in Italian, so it has double meaning. You can pick the one you prefer. So as I said, I have had several people who used it and found that it was pretty good at recovery. I have also tested the tool on a few different cases. Actually, I tried to build very difficult test cases to see how much I can go with the limits of the software. And in a specific case, I built a test case where there was no boot sector, no backup boot sector, and also I did destroy the first few records of the MFT, like the first 5 records, which are containing basically the record pointing to the MFT itself, the backup file, and the root directory. And then I tried it into a few different software. So this was an intentionally difficult case, and test disk did not find any partition. Autopsy failed to add the data source. This was a bit surprising. Actually, I have to tell you, this is a result from a few years ago. I think it was since 2016 or something like that. But I was expecting that it will had the source and then tell me there are no partitions. So this is unallocated space, but instead it failed. Maybe because I completely erased the partition table. I don't know exactly why. And then I tried it with RecuperaBit, and that was 1 gigabyte disk image with several files, pictures, text files, executables, and other stuff. And RecuperaBit basically rebuilt the whole thing. It rebuilt the directory tree correctly, and it was able to restore all of the files, which is pretty nice because that was actually the whole point of doing all of this. So yeah, this was a general overview on how it works. Actually, I did not include screenshots of RecuperaBit basically because it's a command line tool and it's pretty straightforward. So you call it with a disk image, and then you wait for it to scan the whole image, and then you can ask it to see the list of partitions. Then you decide in which partition you want to restore files, and then I don't know, you can say restore the first partition from the root node, and then it copies everything into the output directory. There's not much more than that. Yeah, it's pretty basic in the interface, but it's still working. So there are some aspects that that might be improved actually, and that I plan to address in the future. So here Here's an overview of what I think RecuperaBit could use as improvements. But this is a list that I've written, and as a wish list or plans for the future. But if you think that there are some other aspects that have to be improved, please get in touch so we can see if a lot of people say this feature is useful, maybe it can be implemented. But if you think this other one is not so useful, maybe there's no point into doing that. So there are three main topics for this. I will tell you about the user interface, input-output capabilities, and performance. And yeah, this last point is especially important. If you have already used it, you know why. So user interface is pretty basic. As I said, it's a command line program. It's not very convenient in some cases because it doesn't really give you a lot of feedback while it's doing stuff. So it prints a lot of logs, but it doesn't have a progress bar currently. So what I plan to do is to add a progress bar with the QDM module probably. And instead of printing all the logs to the screen, I plan to show some logs on the screen while other logs should be saved into a file, either a text file or a SQLite database. Let's see what I came up with. And the command line is also a bit basic. It doesn't support editing and history, so it could be a good idea to rewrite it from scratch, basically. So the core of the software is already done, but the texture user interface needs a bit of improvements. And then what I'd like to do is to also make it available as a package, so you can install it with PEEP. Now, for the I/O capabilities, currently RecuperaBit reads only raw images, which is a bit inconvenient. If you have NKS files, which is pretty common, you need to use an external tool like Xmount in order to translate it on the fly to a raw disk image. So it would be really nice if you could read E01 without external tools. Sometimes when you restore the files on an existing NTFS drive, it makes a lot of mess, and it can break the file system because there are some special characters into some file names, like the $sign in the front of file names, which doesn't play very well with NTFS as a destination drive for recovered files. So in this case, I plan to check this before recovering files, and also to keep timestamps because this has been asked a lot before. I don't know, maybe some other kinds of output might be useful, maybe L01. I don't really know. How I have to see if it's the case. Last point is the most important one. It's performance. This is the most important and common complaint because I see a lot of people trying to recover very large drives and very fragmented drives, which has been used for years and so on. So there is a double issue here: the speed of working with fragmented drives, because more fragmentation means more found partitions, and so it takes a lot of time in order to try to recover the geometry of all the partitions. And the second issue is about RAM consumption, especially during partition geometry detection. Well, why? Because when I started to work on this program, I was basically saying, okay, let's keep everything in RAM. So I want to make the software fast. I want to make it, let's say, forensic, so it doesn't write a lot even on the analyst disk. And the initial thought was, if the whole directory tree is kept in RAM and all the data RecuperaBit uses is kept in RAM, it's going to be very fast. while it's doing its calculation, because it does several calculations on this data structure. Well, as it turns out, this was my initial idea, and then reality came forward, and then I realized sounds good, doesn't work, because RecuperaBit is not that fast, and keeping everything in RAM means if you have very fragmented disk, which was maybe 2 terabytes, you get to have, I don't know, 20 gigabytes of RAM occupied, or maybe you smash your RAM and smash your swap file, and then you end up freezing the system. I have had users reporting they were freezing their systems. They had to create additional swap files just to run the tool overnight. So yeah, it sounded like a good idea, but it really isn't. So I plan to use a different approach. What I plan to do is to actually have a project file, which is a SQLite database, and use an ORM to map RecuperaBit objects and classes to tables. This will have a double benefit. The first one is that it will break down RAM usage by a lot. And then also, if you save a project file and then you want to come over the disk drive again and do another analysis, you might be able to reopen the project and get RecuperaBit to avoid rebuilding all the things and rebuilding all the tree each single time. So you will get less RAM usage and faster loading times. And then finally, I think that partition geometry detection, as I mentioned it before, is working very well. It's technically speaking, from an algorithm point of view, is correct, mathematically correct. However, given that we have to do some kind of model fitting with some possible outliers, actually the correct solution would be to use some ransack method or some other kind of statistical methods in order to speed up the results. In the most common case, it will speed up things by a lot, but still the results can be verified after applying ransack. So you can apply ransack in order to come up with solutions fast, and then you can check the solutions to see if they are correct. And yeah, so combining these two kind of aspects will probably make RecuperaBit faster and less resource hungry. So it will be beneficial to all users. This was about everything about the future plans, and also about my webinar today. So thank you very much for your attention. I think we have time for a few questions if there are any. So
awesome.
Thanks.
Thank you guys. So thank you, Andrea. So now is definitely the time to ask questions if you have not asked them yet. Since we're running on time, I'm still going to go to some questions, so we will run over. I just want to remind you guys that this is recorded, so if you do need to leave, you'll get an email. You'll get the link tomorrow, and you can always come back and watch the Q&A session. So with that, let me go and start asking questions. Oh, and the other thing is when you leave, please answer the survey. All right. The tool recovers both file content and metadata if found. Okay, so sorry, it's as a question. The tool recovers both file content and metadata if found, like timestamp, or just the former?
So actually, it's focused on it's heavily focused on metadata. So if a file doesn't have any metadata, you won't get the file content either. So it doesn't do any kind of carving on files directly. So it starts from the directory tree, and then if it can be read, it reads the file contents. This means if you recover a file, it means you also have the metadata. The metadata is recovered completely when you do an export in CSV or a body file. if you just recover the file contents and you don't save the CSV, you lose some metadata, like for instance the timestamps, because currently they are not exported together with the file. So if you export the CSV, you get all the metadata.
Great. Where can I find the software with the test data sets you presented?
Yeah, so the software is available on GitHub. You can find it on my account, which is on screen now. Actually, the test image, I've not published it currently. However, if you would like to try with that specific toy example, you can drop me a line and I will give you the file. It's about 1 gigabyte.
Hello, this tool sounds awesome. Can it recover files because of ransomware?
Usually when you have a ransomware, it overwrites the file. That doesn't mean that it overwrites the same sector. However, it usually overwrites the file, and the file record points to the location of the new allocated sectors. This means that the MFT entry is pointing to the new content, not the old one. So if the MFT record is completely updated and you don't have a copy of the old record, I think probably you won't be able to recover the old file because you don't know what are the sectors where the old content was located.
Okay. Do you plan to extend to support ext file systems?
Yeah, thank you for your question. Actually, I forgot to mention this aspect because generally speaking, RecuperaBit is developed with a modular approach. It has some kind of structure that you can actually extend with if you write your own plugin. Currently, it's focused on NTFS basically because writing each plugin for each file system is a lot of work. But there are some possibilities because you can write your own XD plugin, for instance, and still be able to use the tree reconstruction, the bottom-up reconstruction, which is automatic. However, you would then have to add, for instance, your own logic in order to extract the file contents for each kind of different file system that you want to support.
Great. We also did get several comments saying thank you so much for the tool and the time. So I just want to let you know. I'll send those to you later. Oh, and more questions are coming in. What commercial tools have you tested it against?
I have tested a few. Actually, I don't remember all of them, but I remember I tested against Get Data Back, DMDE, Restorer Ultimate Pro, and a few more which I actually don't remember, to be fair. But I found that the most similar in powerfulness and performance are Restorer Ultimate Pro and the MDE. They are pretty similar in results. Some other tools did not fare very well.
And are cross-linked partially overwritten files detected?
Sorry, I didn't get the actual question, sorry.
Are cross-linked, in parentheses, partially overwritten files detected?
Well, if you have partial overwritten contents, you will still have a working MFT entry maybe, and then in that case, the MFT entry will still give you file names and timestamps of the file. Maybe if you get to the file content, you will find parts of the content. But essentially, what we are doing here is that we are relying on the MFT. So if the MFT tells me that in this sectors there is a file, I'm gonna read those sectors and I will take for granted that that is the file content. It could be partially overwritten by some other bytes that were put there for some reason. So it might not be very easy to detect that there was a partial modification to the contents.
Okay, great. So thank you so much, Andrea. And thank you everyone for joining us. We hope you learned something and did find this useful. If you have any additional questions and you want to reach out to Andrea directly, you can contact him at andrea.lazzarotto@gmail.com or on Twitter. All of his information is, or at least his Twitter handle is up there. I'll send out an email with that information tomorrow along with the link to the recording. And to check out all of our upcoming webinars, go to osdfcon.org/webinars. Our next one is scheduled for March 31st about computer autopsies, and we'll also post our cyber triage webinars there. So if you ever want to attend a demo. As mentioned a few times already, there's a super short, quick survey that should take you just a minute to fill out. So we'd love it if you do that so we can continue to improve and see the kinds of things that you want to hear about on future webinars. So that's it. Stay healthy out there, everybody, and we hope to see you on the next one. Bye.
Thank you. Goodbye.